GCSE required practical investigating electrical components, the diode. Here's the circuit diagram that we're going to use. You'll notice that it's not the same as the exam board recommended circuit diagram because that doesn't work. This circuit gives us the ability to change the applied potential difference in very small increments around about 0, and that is what you need to do to be able to reveal the component characteristics for the diode. Here's the circuit set up to measure the electrical characteristics of the diode. We're going to start with minus 6 volts potential difference applied to the diode, and then increase that in 1 volt steps until you get to 0 volts potential difference. You can see that we have taken the positive connection from the power supply, run that through the ammeter, and then to the diode, thus, and then back to the negative supply on the power supply. Here are the readings from the diode characteristic curve for the negative potential differences. You can see that all of the currents are at 0 amps. Now we need to take the measurements for the positive potential difference as applied to the diode. And to do this, we'll just reduce the potential difference back down to 0 and change the polarity. Now this is where we need to increase the potential difference in very small steps to reveal the correct characteristic. So what we've chosen to do is to increment by 0.1 of a volt. So we'll start off as close to 0.1 as we can get, and this is for this supply is 0.13, and then we'll increase by 0.1, 0.2, 0.3, 0.4. Go all the way to 1.0 volts. Now that can, depending on your diode, give quite high currents, so just be careful of that. I wouldn't exceed, say, 3 amps. It's your absolute maximum on the diode, only if that's a very good quality diode that's capable of taking that current. And here's the full set of results, and you can see that all the way at 1 volt potential difference we've got quite a large current of 2.39 amps. So now the job is to take that information and plot it on a line graph with potential difference on the bottom, on the independent axis, and current on the side as the dependent variable. And here's the graph I've drawn showing the characteristic curve for the diode. It's quite a large change, but it gives the standard response that you'd expect for a diode and is nice and clear.